Page 32, here we go. And I'm gonna make a note here right off the top, and I'm gonna highlight that so that it sticks out when you flip through your notes. I'm gonna say that this inequality right here, what you won't see here is a constant. I don't know if you've realized that already. There's no whole number or a number just kicking around on its own, right? So no constant. Okay, there's no constant, and maybe that part I will highlight catches your eye. What does that mean? It means that this line, the boundary line, will go through origin, through the origin, right? It will go through the origin, and the origin is 0, 0. Okay. So what does that mean? That both your x-intercept and your y-intercept, when you calculate it, you're going to get 0, 0, right? Like origin is both. It's the x-intercept and the y-intercept. So it's not really going to help you. It's pointless to find the intercepts in this case, okay? So I'll write that down, okay? It is pointless to find intercepts. So we need to treat it a little differently. But it's not to fear, it's very doable. If you were to, what I always tell you, hey, I don't like it this way, let's bring things over, you would get this. You would get x minus y, right? The y comes over is less than 0. Because there's nothing left on the other side. There's no constant. And then you're like, well, Mr. Dixon told me don't worry about intercepts, right? I told you that just now. Right? Don't worry about finding them. We know it's 0, 0. So we're going to rewrite it. Rewrite already. So we leave the negative y on this side, and instead we bring the x over to the other side. And when the x comes over, it's negative. Like that. And we don't like negative in front of the y, so we're going to go -1, -1, right? Divide both sides by -1. Flip alert. I'm going to make it face the other way. Like that. So this is my inequality. Let's go ahead and say already this is going to be a dashed line. True region is going to be above, right? Where am I going to shade? I don't know, Mr. Dixon, you keep on messing me up on this one. It's a system, right? So we're going to shade the opposite of where the true region is. So we're going to shade below. Okay, so we're making a little disclaimer there. But I still need another point to graph this thing. Because I only have 0, 0. I need another one. Okay, so what you do is, to get a second point, dot, 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 right? Let x be anything you want. Let x be number of your choice. But be smart about it. Don't just pick a really large number. Pick something that's within what you already have. Okay. I'm going to let x be equal to 5, let's say. Okay. if x is equal to 5, then y is also going to be equal to 5. How should I do this? I need you to see what I'm trying to do here. Because y, if we take the boundary line, if we get rid of the inequality and just say, hey, we're considering y is equal to x boundary line. Maybe that's what I'll do first. Y is equal to x is the boundary line. So y is equal to 5. If you plug in, if you say x is equal to 5 and you plug it in here, then it stands to reason that y is also equal to 5. Okay? So therefore, second point is 5, 5. And I made a big stink about this. That you don't have to, obviously, in the future, write all of this down. But you know for sure that one of your points is going to be 0, 0, and the other one you have to create, right? I could have let x be equal to 10. Then if I plug in 10 there, it would have been y is equal to 10, so 10, 10. It's the y equals x line. Do you remember that from IPR? Y equals x line, when they're both the same as you go up. So let's now, we can graph this one, but I want to still do this one as well before I move on to this one. So let's cut it here. And on this one, you should know, okay, there's a constant there, no problem. It's just like before. X-intercept, Y-intercept. Let's find those y-intercepts real quick. When y is equal to 0, x is equal to 6. So 6, 0, done. For the y-intercept, x is equal to 0, so it's 2y is equal to 6. See how I'm doing equals here as well, because I'm dealing with the boundary line. Right? Divide both sides by 2, y is equal to 3. This is 0, 3. So there are my intercepts. That one I can do just as before. And then let's rewrite it. 2y is less than or equal to negative x plus 6. Divide both sides by 2. And so it's negative 1/2, right? X plus 3. And you just, there you have it. That's your inequality. This is dashed as well. True is below because it's less than. I will shade above. Okay? I'll shade the opposite region, reverse shading. Before you do it on paper, please enter this on your calculator. Okay, so because sometimes the points of intersections may land outside if you're not careful, outside your grid. So clear everything, enter it. So negative half. You should do this with me just to make sure you know how to type this in and how to deal with it. And watch the second one, right? It's y equals to x, that's it. You just go x on your y2. That's it. And let's hit graph. My window is probably going to be way off because I was doing other things. Yeah. So I'm going to go zoom standard real quick. There you go. So that's what we're expecting. One has a positive slope, one has a negative slope. So obviously we expect them to crisscross like that. And the points of point of intersection seems to be fairly, like it's a small enough point that if we use a window 10 by 10, we'll be fine, right? So let's go ahead and do that. Arrowheads. Please just go ahead and do that. I gave you the grid already. All you need to do is write down x and y and put some arrows down. So I'm going to plot my first one. Let's put a scale down. 5 and 10. -5, -10. Just watch out if I give you, if sometimes the darker lines are not 5s, they're, as we did on the AC, they may be the 4 line. Okay, so you just gotta be careful. 6 zeros right here. 0, 3 is right there. it's dashed, so I have to be careful. So I'm basically reviewing two inequalities with you here. This is a system. So I graph it, I write down the inequality somewhere. Then I do my second one, which is 0, 0. And if you just had 0, 0, it doesn't help you. So we created that second point, 5, 5. So we're going to go 5 and 5. It goes right here. That's my second point. And now I can graph. That's also dashed, right? Just so you know, like the way I teach this is the way I found it most effective. Students were most successful, but it doesn't have to be done exactly the way I do it. If you find your own way, you go for it, okay? So the first line, I'm supposed to shade above. I go back to I'm going to label before I forget. This is the y is greater than x line. So I go over to my first inequality and I shade above. I'm basically getting rid of what's not a solution here. There you go. And the second one I'm supposed to shade below. So you go to that line and below would be under it. Right? So what's left over is our solution region. And I really want to emphasize that, right? Because for my first line, if you just focus on this line, the true is just under it, right? We've determined that. If you do your second line, where's the true region? It's above it. Right? Therefore, this is the only section that's true for both of them. That's why we call this the solution region. Okay, so it works every time. All right, so now the POI, the point of intersection, which is going to give you a full mark usually, and sometimes there's going to be more. Is going to be more than one. So that is the POI right there. Let's go ahead and find that, and it should be approximately where it is on your graph, if not exactly, right? So second trace 5. You only have two linear equations in there, so just hit enter until it finds that. So that's 2, 2. And you know what? Because there's so much work already, I don't ask you, like if you forget the keystrokes on this one, I'm not gonna worry too much, because you do need to do a bunch of work to even get to that, right? You can't just type this in and get that POI just like that. You have to do a lot of work beforehand. So there it is, POI. That's very important. That's this guy right here. Okay, and then one more. Where are we at? 10:04. Okay. What I'm going to do after this, I was going to do 3 inequalities already, but I think that's going to be too much for today. So I'm going to give you a chance to practice some more of the 2 inequality questions that are before this one. Okay. So is negative 12, 7 a solution to the system? So let's see here. Negative 12 would be somewhere over here, and 7 would be here, right? We can tell that it is, right, visually, but I need you to do this algebraically, right? If I ask you that, you need to show it. So let's do this. I'm going to write down the first one I was given, and I'm going to plug that in there. Negative 12, right, for x, plus 2 times 7 is less than 6. Let's see if that's true. So negative 12 plus 14 is less than 6. This is 2 is less than 6. That's true. That checks out. So far, so good. Okay. Then I'm going to write down the original, the second inequality, and I do it in the original form. I don't mess around. I don't use what I've rewritten just in case I made a mistake. X is negative 12, so you plug that in, and y is 7. This is also true. Right? Therefore, negative 12, 7 is a solution. Because it is true for all the inequalities that are present there. So it is a solution. You have many solutions in this case. Anything in that solution region is going to be a solution. And down the road, we're going to focus on the solution. Okay. So I think 31 and 33, if you haven't done it, are the only ones that are left in this section with two inequalities. So if you want to take the time to do at least one, I'm going to stop here and I'm going to do 3 inequalities tomorrow. Okay.